talk about an aspect that touches everyone, or cuts across most of the aspects of our life today, the persistent, mobile, and toxic substances. And these facts, we put them together in a review paper titled Grouping Strategies for Assessing and Managing Persistent and Mobile Substances. So it's a paper that's it's a group effort from Work Package 5. And I'm just here to present the overview of all of these, and then we can have more discussions about it during the discussion cafe too. So I would like to start by with a broader issue of pollution that most of us already know about, but some few statistics. So pollution is responsible so far for about 9 million deaths per year, and in 2019, about 296 million tons of chemicals were consumed in the EU that were toxic to both human health and the environment. And in the same year, water pollution is estimated to cause about 1.4 million premature deaths globally. And so here are some examples of community impacts of PMT or VPVM substances in the Netherlands and in Belgium. And so I would like to say that, or to think that by safeguarding the sources of our drinking water from harmful substances such as PMT or VPVM substances, we can potentially save lives. This we've already seen a lot about it. There's the CLP criteria for PMT, VPVM substances. But what we need to know is that these criteria cuts across a wide group of or classes of compounds such as PFAS, triazines, triazoles, and benzidines. Now, if we take a step back and learn some lessons from history, from international treaties such as the Montreal Protocol on ozone-depleting substances, we see that these, for example, the Montreal Protocol grouped substances based on similar properties. And since this treaty was signed, we can also observe that there's a reduction in relative consumption of ozone-depleting substances since 1986, both in the EU and globally. Also, in the Stockholm Convention, for the where substances were grouped according to the structural similarity, if we look into it, we also see that the emission of these substances, such as PCBs, HCBs, and dioxins, drastically reduced, and also the number of registered patents in PubChem database. However, we might tend to think that these were the best solutions ever, but grouping of substances and regulation of substances under the Montreal Protocol based on property-based regulation, we see that some of these substances have been substituted to produce PMT or VPVM substances such as TFA in the end. And in the Stockholm Convention of Persistent Organic Pollutants, we have issues such as regrettable substitution, where P4 is currently substituted by 10X. And so from here we understand that limiting grouping based only on intrinsic properties or structural similarities can lead to either burden shifting or regrettable substitution. So from here we propose two grouping strategies for assessing and managing PM substances. So the first one being grouping based on structural similarity, which I've just previously shown from lessons learned from the grouping on the Stockholm Convention with cases like dioxin. But then an alternative grouping strategy, which is grouping substances based on retained moieties from transformation reactions or persistent substructures. So if we look, we see that this substance, the parent compound, continuously degrades to produce melamine, which is actually a PM or VPVM substance. So this means taking into consideration both the parent compound and the transformation product is important for grouping or managing these PM substances. And so we, with these two proposed grouping strategies, we, especially my colleague, Emma Schymanski, she used cheminformatic tools to predict these properties for groups of substances in databases. So we first used PubChemLite, which is PubChemLite is a data set of about 350, well now it's a database of about 350,000 environmentally relevant compounds, and we predicted the mobility properties for these compounds and found out that about 41% of these compounds would be considered potentially mobile. Meanwhile, 21% would be considered potentially very mobile. And also, to further test the second grouping strategy, we did predictive studies for substructural groups of potentially PMT or VPVM classes of compounds, such as melamine, benzotriazole, OCD, PFAS, and benzidine. And for this, we found out that the majority of compounds containing melamine, benzotriazole, OCD, PFAS, and benzidine substructural groups with molecular weight less than 300 that fall within the applicability domain of the models were potentially persistent and mobile. So from the paper, one of the key points we found was, kind of obvious, that cheminformatic tools can be used to predict PM and T properties for compounds, thereby supporting regular testing and grouping. But also, like we've been saying since morning, there's insufficient data for these accurate predictions. We also realized that, and also I think all of us already know, that there are so many PMT substances, from hundreds to thousands of potential PMT substances. Now, the major issue is how do we assess and manage these huge number of substances? This is also, these we can talk about during the discussion cafe as well. I think that's also why we're here, to discuss some of these and come up with points how to prioritize and manage these huge number of substances. Also, due to lack of high quality data that in turn limit predictive accuracy, we suggest that generation of experimental data using both in vitro and in vivo studies to could go ahead and support in silico techniques, and that aside from focusing on just the persistent mobility and toxicity properties, we could also use additional data such as exposure, emissions, consumption patterns to prioritize certain PMT substances for management, regulation, and assessment. Now, what is also very important that we've been talking about is open science and community efforts. So we need to work together. I've heard a couple of open science ideas. I see also, I think a couple of colleagues said they paid for some data, but if we work together and actually share information, we could actually achieve a great deal to prevent, to prioritize, and remove PMT substances from the environment. So a great shout out to Environmental Cheminformatics Group, and to my supervisor, Professor Emma Schymanski, and my colleague Emma Palm, and all the other work package members, and of course to all of you for listening. If you have any questions, I can try to answer all your questions, but that's going to be really hard because this is why we're here, to manage these huge substances. But then we also have a discussion cafe where we can exchange ideas and come up with better strategies. Thank you very much.
ZeroPM, Zero Pollution of Persistent and Mobile Substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 101036756.